now is actually dpress.new, which is coded 1 and 0. And then our IV will be A1.new. A1.new is what? Gender and also income. Only these two lah, just to give you some idea how to make the interpretation. Analyze, regression, binary, logistic. Okay. After that, you can see here is dependent, right? So please insert your dependent variable, which is the dpress.new. Don't put your dpress.cat, dpress.new. Logistic regression must only read those 1 and 0. Cannot read other things than that. Otherwise, it will become error on the model. Okay, and then put your covariate. In my data here, covariate will be A1.new. Our new gender that already been classified as male and non-male. And then I'm going to put the income. The income you can just put straight away in our covariance. Okay, done? Done or not done? After that, you click OK. No, not yet. You click categorical first. In this categorical, you have to ask the covariate of A1.new into the categorical covariate. Categorical covariate means what? We are indicating the A1.new as our indicator. So, contrast indicator change as the first. So, you change lah. Letak dia sebagai A1. So, dia predict pada male. So, when they predict pada male, so the inverse will be non-male lah, which is the female. Something like that lah. Okay. This one, if you want more explanation, you can see a lot of people already doing it lah. Okay, and A3, do you want to click the categorical? No need, because the A3 is continuous data already. Even though it's not normally distributed, we don't care about that because this is logistic regression. To make this one simplified, I can click OK, but before that, I want to explore first. Go to the save. Go to the save. You want the unstandardized residual rigid probit? Never mind. You cancel. I don't want to explain the complex mechanism of it. Go to the option. Okay. On the option, you go to the Hosmer, Lameshau, Gunnar-Sofit, and CI for the exponential B for your 95% confident intervals. Okay. This one, logistic regression option. You are going to request for Hosmer, Lameshau, and also CI for exponential B. After that, you click continue. And then style, let me see. Okay, style, no need to click. Bootstrap also no need to click. Okay, after that, this is the enter method. You got the forward, you get the backward, walk, and so on. Let me see first. This one option already select. Save. I'm afraid if well, never mind. This one, influence or whatsoever is the complex rule of analysis. So after that, you are going to click OK. Have you clicked OK already? Why I don't click OK? Because I want to stop it. This is the logistic regression. So you are going to click OK and the data is already there for you. Okay, I'm going to run it again. So this is the output of our logistic regression. I'm going to export it first so that we can interpret it nicely. BLR, binary logistic regression. So, binary logistic regression. I may not have time to show you how to do it in the Word condition, but I hope you can refer to this table as the example, how to interpret it later on. B, walk test, P, and odd ratio, and notes for the R square and also the model chi. So, if you already familiarized with the simple linear regression, actually binary logistic regression also almost want to be similar. But it's not similar. Don't say that, oh, it's similar. No. It's not similar at all. So we got two kind of block. This is the beginning block. This is the null block. Before we predict the occurrence. Before we predict the occurrence means that before we predict is as one event that you are interested on. Sometimes your event will be happen, not happen. 0 or 1. Sometimes your event will be dead or live. 0 and 1. Up to you what kind of event that you are trying to measure. The first one that you need to understand is when we go into the step 0. Step 0 means what? We don't put anything inside our model yet. We don't predict it yet. This is our null. Okay, this is our null and this is what they are going to be happening. No problem. Go into your block 1 method. Okay, in this method, the first one, why I laughing? The first one, you look at the step 1. The step 1, you look at the model and also you look at the chi-square of the model. This chi-square of the model indicate the significant value is 0.193. What does that mean? That means it's not fitting the model lah. That's all. It's not fitting the models. This omnibus test for model coefficient is actually we need these particular things to be significant. If it is significant, then it's good. Why? Because it's fit the model. For the step and block and the model. This one, the third one, the model need to be fit. Of course, not fit because 3.2. We need to have the fit model for 2 by 2, at least 3.8 or 4 point something in terms of the chi value. Then you got the statistical significance will be statistically good lah. And then you can see also here the step 1, -2 likelihood ratio, Cox and Snell R square and also Nagrel R square. This is what I call it before. This is what we call pseudo R. What is this? Pseudo R. Some people will report the Cox and Snell R square. Some people will report the Nagrel Kerke R square. If you ask me, I prefer to use the Nagel-Krakel rather than the Cox and Snell. So to make your thesis much more thicker, you report both. But to be true, actually, you can choose either one based on the different statistical justification lah. Some said that the Cox and Snell R square are not the most sensitive one as compared to the Nagrel R square because their coefficients are limited. But the Nagrel R square are much more representative lah, similarly like the R. But it's not R, pseudo R. Therefore, if you ask me, I will go for Nagrel. I will go for this one. I'm not going to report my Cox and Snell. So, Nagrel R square boleh bayangkan. So, kalau dalam R square in our simple linear, we are talking about how many explained variance, X towards Y, right? But this one never extrapolate like that. It's very dangerous. Never extrapolate like that. How you want to extrapolate based on this Nagrel R square? You are only talking about the odds. Okay, the odds. Okay, that is the idea lah. And then you pergi kepada Hosmer and Lemeshow test. This one should be significant or not significant? Yes, not significant should be good. Hosmer and Lemeshow test, if I'm not mistaken, is talking about the... I'm not sure about this. I'm so sorry. But usually, I'm looking into this one, the classification table. Classification table is actually very important for you to look at the percentage of correct. Your percentage of correctness actually is low. The best percentage correctness prediction should be more than 70%. Preferably 80% lah. This one, how many? Oh my God. Not predicting very well. That means the odd ratio and the logistic regression for this particular model for the depressions being predicted based on these two X. What is your X? Income and age are not very well. So that means your another X will be much more useful. Oh, okay, 423 already. Okay, wait. Okay, this is the variable in the equation. This is B. Before this, what is this B for? Beta kan? Before this, we got the constant or intercept? We got the intercept, right? Okay, remember, the B here is not... Okay, 5 minutes. The B here is actually not the standardized beta. Okay, the B here is what? To make your head much more understand and clearer. This is talking about log odd. You understand about log odd? You must understand the odd first. The probability of occurring of the odds and then the probabilities of log odd. Or whatever it is to make it simplified version, the B actually talking about log odd. Or we call it as the odd of the log odd lah. What does that mean? The increase of this particular odd will increase this one. If you see the A1.new, that means the increase of this particular odd will decrease 1.4 this one. Decrease 1.4 means that it is favor towards the male lah, rather than female. Okay? But this one is significantly predicted or not? It's not significant because the SIG is 0.145. So what about our A3? A3 is what? Income. Our income, log odd are very meticulously funny. Correct or not? And you can see the exponential B is equal to what? You understand what is this? You know why I laugh? You know what this mean? This means we fail to reject the null hypothesis. That means the exponential b is equal. The OR is equal to 1 means that we fail to reject the null. OR is equal to 1 is actually our null. So it's very good because we can see that exponential b is nothing to do with anything regarding the predictive capacity towards predicting the y. So your income also cannot predict the depression. So the exponential b, the 0.22 is actually not significant because the SIG value is more than alpha, and your 95% confidence interval also is not more than 1. And then your constant, no need to explain about the constant. You have to focus on the A1.new and also A3. So based on these two variables, what you can conclude? Based on these two variables, we can conclude that they are nothing to do with the age, and also, they are nothing to do with your income and nothing to do with your gender that may influence the occurrence of depression. That's all. But this model is not good. In addition, this model is not good. Why? Because of the predictive capacity, percentage of the correct classification is not good, and then the odd ratio also cannot represent something on the IV and DV, and furthermore the Nagarakel R square also show the very low R Nagarakel R square. Okay, so far, does that make you understand a little bit or make you further don't understand at all? Never mind. After this, for those who required more detailed explanation for this particular logistic regression, you can ask me.